Hello there, welcome again to our Patron tutorials. My name is Germán Ramirez. I'm from 6th semester of Mechanical Engineering at CETYS University at Mexicali, Baja California, Mexico. And today we will continue with the workshop that appeared in the tutorial PAT 301 or PAT 301. Today we're gonna do the workshop number 11 that is titled as using lists and groups. This will help us to learn how to manipulate entities like nodes, elements in different groups and lists that will help us get the best of this tool. So let's get started. First of all, what we're gonna do, we're gonna make a new folder, and because in this workshop what we're gonna work with is with a fairing. The name of the folder, I will name it fairing, and like I said in the past videos, it's best if you copy the shortcut for your inside your folder, and right there open your patron. So the files, in that way, the files that the patron generates save inside this folder. We wait for the program to open. Once it opens, we go to menu, file, and we open a new database. This new database, we're gonna save it inside of the folder that we just created and name it the same as the folder. We're gonna use the tolerance as default and make sure the analysis code is MSC Nastran and the analysis type is structural. Next off, where we're gonna start is by making the geometry of the fairing. To do so, we go to geometry. We will start making a point by method of XYZ. The first one of the point coordinates list is gonna be 13. We're gonna turn off auto execute. It's gonna be 30 0 0. We're gonna click apply, and our first point is created. After that, we're gonna create a curve, also by method of XYZ. We're gonna turn auto execute off, and we're gonna enter 100 0 in X direction, 120 in Y direction, and 0 in Z direction. As the vector coordinates list, and then the origin coordinates list we're gonna put as 50 in X and 40 in Y. We're gonna apply it to it, and we got our curve. We're gonna turn on the show labels icon that is on home. That is gonna be this one, and that way we can see which ones are the labels of our points and our curves. And we're gonna also make bigger the points in here on point size. There we go. You can click again to make it smaller, or you can click to make it big. We're gonna stick in big. So after that, we're gonna create another curve, but now by method of point. We're gonna turn off auto execute. Starting point will be 0.1, and the second point will be 0.2. Select apply, and we got this part of the geometry. Illustrated here are curves that represent the basic geometry for the fairing. These curves will be revolved 360 degrees to get the final model. So to do so, we will we need to create a surface. The surface we will create, it will be by the method of revolving, because we will make this geometry that we made, we'll make it revolve around a vertical axis. So in that case, the axis, it will be coordinate 0.2, and the total angle will be of 360 degrees. So it makes the whole turn around the axis. We will turn auto execute off. We will, under curve list, we will select curve 1 and curve 2, and we will select apply. So we can view a little bit better. We will go to viewing angles, and we will select 30 0 0. So in that way it will be applied, and there we go. We can see it a little bit much better. And now, to have a clearer visual of the model, what we will do, we will select on display, next on geometry. After geometry, we will enter 3 as a number of display lines, and we will select apply. After that, we select cancel. Now we will create a finite elemental mesh so that 4 node quad elements are created every 10 degrees along the circumference on the circular edges. To do so, if we want every 10 degrees, well, if a circle has 360 degrees, we will need a total of 36 mesh seeds. So we will go back to, we will click here cancel. We will go to meshing. We'll go to mesh seed, uniform, and we will have the number of 36, one for every 10 degrees. After that, we will select the curve list, and we will select the part upward. There we go, and it already created. Next up, what we will do, in the vertical direction, well, in the Y direction, we will define a smoothly transitioning mesh density. For this, we will select here on mesh set. We will change uniform to one-way bias or bias. After that, we select L1 and L2. In L1, we will give a value of 7, and for L2, we're gonna give a value of 10. We will turn auto execute, and we will select curve 1. After that, we select apply. Next, we will change the values. For curve 2, we will select L1 4, and L2 is gonna be 7. After that, we select curve 2, and we apply it. As we can see, it's a little bit more separated on the top than on the bottom. As you can see, that's the difference of mesh density, thanks to the one-way bias. Okay, now that the mesh seeds are created, we're gonna proceed to mesh our model. We will mesh the model using quad 4 topology. So in that way, what we will do, we will go to create, we will change it to mesh, and we will leave it like surface. We will select, make sure here is quad isomesh and quad 4. Quad 4 means that it's gonna have 4 nodes at each quad. So in the surface list, we're gonna select the whole model. Once we select it, we're gonna put it in apply and see the meshing, how it produces. Since it's like a lot of information, and you cannot see very well, we will remove the display lines by clicking on home. Then it's gonna be the display lines button. Display lines button is this one. Okay, now that we turn it off, we're gonna remove the labels by the hide labels icon. The hide labels icon is this one. Okay, now it's a little bit cleaner, and by the end we will make smaller the point size. So now it's a little bit cleaner, as you may see. Now, to make it a little bit more cleaner, we will erase the film. Um, to do so, well, not quietly erase it, just make it disappear for a while. To do so, we'll put on, I will right click here, I will go to plot erase, and after that I will erase film. There we go. Now it's quite better. So we press OK, and after that what we will going to do is we will mesh these horizontal circles with two noted bar elements. We go here and create, we mesh, but instead of surface it's gonna be curve. The topology needs to be bar 2, and the curve list we will select the 3 of them by leaving the shift key selected. Once we selected the 3, we will select apply, and so we can see better. Maybe you get the question of if it really happened, if it really mesh the whole the circles. But first of all, I don't know if you saw that it was yellow and now it's green. Also, another way to view it is seeing the command output. To do so, you can extend it, and here we see that fem create mesh curve. It generated the bar 2 in the surfaces, and they were created 37 nodes and 36 elements. Also, another way to verify is with the next steps. What we are going to do, we're gonna go here on verify. I'm sorry, verify element, and we will analyze its boundaries. We will analyze the free edges. We're gonna plot it, and here we can see the edges without the mesh and anything. These are the edges. Then we're gonna equivalence. We're gonna make an equivalence. All tolerance cube. We're gonna apply to it, and once we did the equivalence, we're gonna go back to verify. We're gonna see again the boundaries, and here we can see the yellow line. And the yellow line does not indicate quad force with free edges, but the presence of bar 2 elements. So that's quite impressive. So the next thing we're gonna do is to replot the fem. To replot the fem, you right click, then we go to plot erase, and we will plot the fem again. Plot. So yeah, there we go. We plotted our fem again, and right now we have like the geometry and the fem again. If you want to make sure, you can plot all, and yeah, we got the geometry and the fem. So for the next step, we are gonna select OK, and we're gonna go to group, and group we're gonna create. The thing is, we're gonna create a group called fem that only includes the fem, so the finite element model. So we write the name fem, and for the next thing, since in this group we only want the fem, we're gonna select here on post all other groups. Once we select it, we're gonna change here group contents. We're gonna put add all fem, and then we're gonna select apply. And there we go. Now, as you can see, we get two groups, fem and default group. The default is the one created by whenever you open it, our database, and the other one is the fem, the one that we name and created. So what we're next going to do, we're gonna make our first material. Our material is gonna be of aluminum. So we go to material, we go to properties, we select isotropic, and after that we will give a material name. The name is gonna be alum underscore 1. We are gonna put the properties, select input properties, and the elastic modulus is gonna be 1.0587, and gonna be the Poisson ratio is gonna be 0.33, and the density, it will be 2.6 E minus 4. Okay, now we can make apply to create our new material. As we can see, the material created. Also here we can see material created. The next thing we're going to do is we're gonna create a second material. This material, we're gonna name it aluminum 2, and it's gonna have this new material is also aluminum, but this aluminum 2 is gonna be applied to the bottom part of our fairing, since it is tapered. It has a little bit smaller elastic modulus and density. So in that case, we're gonna change its properties. Since it's tapered, it's gonna be 118. I'm sorry, the elastic modulus, it goes higher, but the density is gonna be a little bit smaller. It's gonna be 2.4. So we press once the Poisson ratio stays the same. So we press OK, and we select apply. As we can see, our second material is created. Now what we're going to use is a tool that is called field. Those fields help us represent the varying thickness and temperature distribution. As we mentioned before, the fairing is tapered, it's quite thicker in this part on the top, and it goes a little bit slimmer on the bottom part. So to represent this as a formula, what we will do is go into field. We select field, we put create spatial, and put a PCL function. The field name, the first one is gonna be thickness, and the scalar function is gonna be 1.5 minus apostrophe y divided by 160, and we're gonna select apply. Now we're gonna staying in the same, create a special PCL function. We're gonna change from thickness to temperature. Now we're gonna change the function to one a little bit more complicated but small. It's gonna be 200.0 minus 150.0 divided by 160.0 times apostrophe x. So this is our scalar function. Next, we're gonna just click apply. So there we go. It says field temperature created. We can see also here, we can see the two existing fields with its respective scalar function. Next, what we're going to do, we're going to create 2D element properties. To do so, we're going to use shell. We go shell, we select here, and in the tab of properties, 2D properties shell, or we can manipulate it from here. Now we're gonna, the property set name is gonna be prop underscore 1, and it's gonna be, we're gonna select input properties. No, back. Input properties first. In input properties, we're gonna select aluminum 1, and now for thickness, what we're going to do, since we already created the field, we're gonna select here, and we're gonna select the field of thickness we used earlier and that we made earlier. We're gonna select OK and select application region. To make it correctly, we're gonna see if what the preferences are selected by. We're gonna go preferences picking, and we're gonna choose enclose entire entity, so it becomes easier for us this next step. So we choose close, and after that we're gonna put it to the front. We're gonna select members. We're gonna choose the quad element. We're gonna select the shell element, and we're gonna select this way. And yeah, there we go. There we go. We selected our elements. So we're gonna click add, okay, and we're gonna select apply. And there we go. We created our property number 1. So now we're gonna create property number 2 for the bottom part of the fairing that we're missing. So we're gonna change the input properties. This, instead of aluminum 1, is gonna be aluminum 2, and well, the thickness, it's already in the function of thickness, so we are gonna leave it like that. We select OK. Now we're gonna select the application region. We select application, select members, and we're gonna select this way. We're gonna select the bottom part without having changed the preferences picking. And now we select, and we select add. Remember that we stayed in shell element, and we select OK. And once finished, we're gonna select apply. This one is an error. I think we missed, it didn't quite get our material name. We're gonna select it again, aluminum 2, and thickness. Okay, we're gonna select apply. Okay, there we go. Maybe there was a problem while we were inputting it, or maybe didn't quite get that we changed we changed the material, but nevertheless we created property number 2 that if we want to verify, we can double click on it and we can see how is the material it was made and which one is the thickness that is right now. It's given by a function. We can also see property number 1 that is of aluminum 1, and that's so what we're now going to do. Once that the property is already defined, we will define the model's varying temperature distribution. To do so, we're gonna go to loads BCs for the model's varying temperature, and then we're gonna select we verify create temperature nodal, and we're gonna have a new set name. Set name is gonna be temp, as in temperature. Right now we don't have existing sets. We're gonna input data. As you remember, the temperature we already make some spatial fields. We're gonna grab the one that we made of temperature, and next we're gonna select application region. For this, instead of geometry, we're gonna select FEM, and select nodes. We're gonna select all the nodes, and we're gonna put add. We're gonna press OK, and then we're gonna press apply, and there we go. All the load BC temp was created. As you may see, there was it is displayed all the temperatures. As you can see how the temperature varies. This means that it worked well. But for the next thing, we will turn off the temperature labels in order to get a better visualization of the model. To do so, we go to display, and display we go to load BC element proposition, and in loads BC we're gonna look for temperature. We're gonna uncheck it, and we're gonna go to apply and cancel, and as you may see, now we can see better and work with continue working with our model. Next, the tool that is very important for this workshop is the use of tools like list. We're gonna go to tools, we're gonna use to list, and we're gonna create one. We're doing this of list. We're gonna use list and groups to filter and group quad elements to certain attributes. The first attribute we were gonna group for is gonna be because of the material it is made. So first of all, we're gonna change, instead of node, we're gonna change to element, and we're gonna leave it as attribute. We select material, and once selecting material, we're gonna choose alum 1. After selecting alum 1, we're gonna set the target list to A, and we're gonna apply. And as you can see, the list A now contains element 1 to 504, which are all the elements that has the property specified of alum underscore 1. So reevaluating what we did was in this group, we put it in this list, we put it all the elements that have alum 1 as property. Now what we want is to have in another list, in list B, to include only the quad element that have a thickness greater than 0.98. To do so, we go to properties. Since this we already finish it of list A, we will select cancel. Right now we'll use it anymore. We will change this the element properties, we will want it to change here. Instead of create, we will select show. We will select thickness, and after thickness, we're gonna select the display method. We want it to be a scalar plot, so it's correct the way it was. Select current viewport. It's gonna be fem, and we're gonna select apply. So as you may see, we can see the different thicknesses that are in our that are in our fairing. As you may see, since the part of the top is gonna be slide more less thicker, and the part of the bottom is gonna be more thick, you can see how it is distributed, the thickness. So what we want to do is in list B have the the elements that are bigger, that have a thickness bigger than 0.98. So once after seeing this plot, what we're going to do is go to tools. We're gonna go to list, and after list we're gonna select create. Now we're gonna create target list B. We can close target list A, and to do target list B, instead we will maintain attribute element, but instead of material it's gonna be fringe value. It's gonna be default fringe, and here is gonna be greater than 0.98. So we have a thickness bigger than that. So we already changed the target list to B, and we select apply, and there we go. We got in list B all those elements that are the ones that have a thickness bigger than 0.98. So now, since we got our list B and list A, we will intersect them. So in that way, knowing that list A has the property of all the elements that have the property of LM1, and list B has all the elements that are bigger than 98 thickness. So we're gonna intersecting them. We will note which elements have a thickness bigger than 98, and also have the condition that they have a thickness bigger than 0.98, and they are of the property of LM1. So we're gonna select here cancel, and we're gonna go to tools. We're gonna select list, and we're gonna select boolean. So boolean, we're gonna close this list B, list A, and we're gonna select content. We're gonna select intersect, so A and B intersect, and in that way we just know these ones that are the elements that comply with the two conditions, and we're gonna replace it on A. So now the list A have the intersection of both of the aluminum one and thickness bigger than 98. Now we press cancel. We're gonna create list cancel. Also the one of the group we're gonna cancel. Okay, now what we're going to do is we want to know which ones of those already intersected list. We want to know which one also of those elements that comply with being aluminum 1 and having a thickness over 98.98 are also have a applied temperature over 230. To know which ones are, we will need to go to load species. We're gonna go to plot contours. We're gonna plot temperature. Once we plot it, we're gonna select existing sets. That is the one we created of temp. We're gonna select that variable. It's gonna be temperature, and the current group we're gonna select is gonna be fem, and we're gonna click apply. So once plotted our temperature fringe, as we can see, we're interested in the part with high temperatures. We want the all the elements that are higher than 230. So we're going to make a new list with these elements that are higher than 230. As we remember, the list A is the one that intersects all the elements that intersect in the first two conditions. So right now we're gonna close it, and we're gonna maintain it here in fringe value, default fringe, but in here we're gonna put it as 230, like this, and the target list is gonna be B. List B, but for it to be okay, we need to clear it, and then we select apply, and there we go. Now on list B we have all the elements that are that have a higher temperature than 230. So now we can close it, and now we're gonna find the intersection of list A and list B by a boolean. So we find all the elements that comply with the three conditions. So we select list C, we select clear, I'll put something else clear, I'll select the intersection. These are the elements that comply with the three, that are the intersection of these two and comply with the three conditions. So this one, these elements I'll add it to the new group. This group I will name it as common underscore quads, and I'll select apply. There we go. Now it is our new group named common quads. So I'll go and post it. So once since it already made, we will go back to, we'll go to display, we'll go to group, we'll go to post, and we will plot our common quads one, apply, and there we go. This is the zone of the fairing that complies with the three conditions. As you can see, the lowest temperature is 223, and the high is 247, and as we can see, is over 223 the temperature. Also, it is made of the aluminum 1 property, and also it has a thickness over 0.98. So there we go. This is a great way. The groups and lists help to define like in a specific part of the model that complies with certain conditions. Now we're gonna do another example of groups. To do so, we're gonna refresh the graphics, reset the graphics. Once reset it, we're gonna go to group. We're gonna create a new one, and this one is gonna be by property set. So when select your property set, the group name will be prop 1 group, and it's gonna be a group that only has the elements that are property 1. So we're gonna select apply. And now we're gonna make a group similar, but it's gonna be of property 2, just of all elements with just property 2. We select apply. So we can see that we're created our 2 new groups. So now to differentiate, to make a difference between them, we're gonna change the color they are displayed with. We're gonna go to display, entity color label render, and the next thing we'll do, we're gonna select here entity coloring and labeling, and gonna be group, and we're gonna choose first the prop 1 group. It's gonna be at wireframe, and our shade color will be yellow. And after this, we will select apply. And now for the prop 2 group, it's gonna be prop 2 group, and it's gonna be hidden line. The shade color, it will be dark blue. And we're gonna select apply. And there we go. So now we're gonna select cancel, and here we have our 2 groups plotted together. If we want to see just one, we can go to group post, and we can just select prop 1 group and select apply. Here we have just the group with the property 1 of aluminum 1, or we can just plot the second one. It's the part of the bottom that it has the aluminum 2 property, or we can plot both of them together. We select shift, the 2 of them, apply, and there we go. Here is our grade fairing using that was made by using groups and lists. So these ones are great advantages that our group that using groups and lists help us a lot in using pattern. So this is all for today. Here's where it ends the workshop. Thank you for everything. Hope you have enjoyed. Please subscribe. We're gonna save it. Please subscribe and give a thumbs up. And if you have any question or suggestion, you can put it back in the comments. And thanks a lot. Hope you have a great day.